Good day, biologists. This video is going to show you how to use the virtual lab on cell reproduction. We're calling it the Cell Cycle in Cancer Lab. In Google Classroom, you will find this document linked, Virtual Lab, the Cell Cycle in Cancer. You're going to open this document. You're going to have your own editable version into which you should answer all the questions and follow all other directions. When you click on this link, it will bring you to this website. Again, you're going to need to be able to use Flash. So look back at the video I made on Friday showing you how to turn on Flash if you haven't. Now, in the bell ringer today, I asked you if you were unable to open Flash, in which case I'll be able to read that and see who's still having trouble, and I can try and troubleshoot what's happening. Or I'm also going to put a version of this lab just in slides that you can use to answer the question to complete this document as well. Okay, so over here is the purpose and the objectives and the procedure. And the first one being that you should click on this TV.
The cell cycle is a complex series of continuous phase.
Explanation
Nucleolus can be
through
clearly
which
seen.
you can answer
The
questions
DNA
in
is copper.
part one here. So watch that and answer the questions. If you need to go back, you hit the back arrow. You hit play if you pause it as I've done. Okay. So that's part one. Pretty straightforward. Now, part two, on the left-hand side of the screen, I've numbered the steps. So in step 3, you close this by hitting the X. In part 3, it says click the microscope. And when I click the microscope, I get a view of slides. Now, I'm not sure why this is already here, but the directions say to grab a slide from the slide box here. So I'm going to put normal lung here. Okay, and those directions are here, but you're going to see on page 2 there is a data table. So in the table of contents here, it has a reminder of the phases with some explanation and a picture of what's happening. But then there's also this box that can be used to label cells in these empty spaces here, these empty rectangles. So your task is to identify each cell that has a box underneath it, a text box. Okay, so I've identified this one as interphase. I'm going to identify this one as interphase. I believe that is interphase. And I believe that one is interphase. Now this other one looks different. That doesn't look like interphase to me, so I'm going to scroll through until I find one that I think matches that. Okay, and I think that's prophase. So I'm going to label that there, and then I can check my answers here. And that sound means that I'm right. So now what I need to do is I need to count the number of cells that are in interphase. So if I count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 cells in interphase. So I would go down here and I would put in 19. Okay. There's one that's in prophase. Okay. And this particular slide doesn't have any in metaphase, anaphase, or telophase. Okay. Then I would need to calculate the number of cells that are actively dividing. So what I would do to figure that percentage out is I would figure out the number that are dividing, and in this case, there's only one that's dividing. And I'm going to divide that by the total number of cells in our sample. So there's one that's dividing, and I'm going to divide that by the 19 that are in interphase plus the one that's in prophase to give us 20 total cells. So you could do this on your phone. You could do it on a calculator on your computer, but there's also a calculator here. So I'm going to do 1 divided by 20, and I'm going to multiply that by 100, and I get a percentage of 5. Now, it's out of 100, so I can either know that number, or if you want to do the calculations, now I need to calculate the percentage that are at rest or not dividing. So there are 19 cells that are not in some stage of division. So I'm going to take 19 and I'm going to divide that by the total number of cells in our sample, which is 20. So I divide 19 by 20, and then I multiply that by 100, and I get 95. Now, having calculated that this is 5, we could have simply just subtracted this from 100, but I wanted to show you once again how to do calculation. Okay, so there's data for the lung tissue. Now I would do, next in our data table is the stomach tissue. So I would do the same thing. I would go through the phases and I would identify each empty box with the correct stage. I can check it when I'm done. If you make a mistake, go back and fix it. And then after that, I'm going to do normal ovarian tissue sample. Then in table 2, I'm going to look at the cancerous lung data. And I'm going to do the same thing. I'm going to identify cells in different phases, keeping track of the data in these tables. Then I'm asking you to graph your data. So using the table above, choose one normal tissue. So you can either do normal lung tissue and cancerous lung tissue, or you can do normal stomach tissue and cancerous stomach tissue, or normal ovarian and cancerous ovarian. And you're going to make a graph using the data. But I want you to use just the numbers of cells. Do not do anything with the percentage, but instead the number of cells in each phase. Okay, and there's a Google spreadsheet shared with you in Classroom that you'll use to make your graph. Remember from the graphing in Google Sheets exercise what you need in terms of a title and data, axes labels, and those kind of things in your graph. Okay, and then finally, when you're done with the graph, you're going to answer these 2 questions. And if you choose, there's an extra credit question here that you can do. Okay. Now, as I mentioned, if you can't seem to get Flash going, and I don't seem to have an answer for you either, then you can use the set of slides that are in Classroom to try and do this exercise as well. But you will complete this worksheet regardless of which version you use. Okay? All right. Thank you, biologists.